Hello friends, सबको नमस्ते. So today in this video we will create a brain tumor segmentation model using a YOLO. Okay, so I already uploaded my dataset in a Google Drive. I just copy the share link and capped this part. Okay, and paste it in this cell. Okay, in the file ID. And when you will run this cell, your dataset will get downloaded in a zip mode, in zip format. You can say. See this downloading. Let me refresh it. See, this is a zip file. You can see it. Now I want to unzip it. Make sure the name will be same, otherwise it will throw error. Now we have to upload the Ultralytics for downloading the YOLO model, pre-trained YOLO model. You can see for Ultralytics we import YOLO. That model is equal to the model which we are using YOLOv9 segmentation PT. Okay, and you can see. Let me show you a YOLO9 how many parameters which we have. Okay, so that you will see how many parameters and in what image size this particular model is pre-trained model, YOLO pre-trained model train on. So this is it. So YOLO9, this is here. See, and the things which we are using is this one YOLO9 CE segmentation. The model pixel size on which this model pre-trained model train on is 640. The parameters it have is 60.5 million parameters it have. Okay, so this is it. This is a pre-trained model, but now we have to train this pre-trained model on a custom data set, which have a data set like brain tumor segmentation data set. And you know that it's containing the YML file, which basically YM file is for, you can say, is a train and validation and test directories. You can where the test train and validation directory present number of classes, which basically give the information about the data set which you have. And see is number of classes one whose name will be tumor, and these are the I have downloaded it from the RoboFlow. Okay, so this is it. Now you have to, and when you have to train this model on a custom data set, you have to use model.train, and data you have to get YML file inside it, present inside it. Then epochs will be 5. I already have a model which is trained on 50 epoch, but for the explanation purposes, I want to train it for 3 epoch. I already have a model which is trained on 50 epoch. So just for after the explanation, I will upload the model which is trained on 50 epoch and show the result of that model. Okay, the image size is 640, and batch will be 8, means the number of images I want in one batch will be 8. And and this is that when I will run this cell, the not detect folder, run folder will be created. Inside the run folder, segment folder will be there. Inside the segment folder, one folder will be there whose name is decided by us, and that is the name of this folder will be this one. And inside that folder you will get the weight folder, and inside the weight folder you will get the weights, best and last weight file. We will use best because we want to use for the prediction purposes, or you can say for the getting the mask we use best model. Yes, save true. Yes, we want to save the best model, or model you can say, or the weight file you can say. Save period -1 means we do not want to save every weight file after end of every epoch. We just want to save the best weight file among the epochs. Patience 20 is basically the earliest stopping, means after every 20 epoch it see that there is an improvement in accuracy, or there is a decrement in the loss or not. If it is not there, if if there is no improvement in the training, that it will stop the training at that particular epoch and save the best you can say best weight file among the epochs or you during the training. Validation true, yes, we want to validate also. And you can see the number of images which we have is of the same, of you can say same grayscale. Different variation we do not have, means variation in sense that flipping will be there, another perspective, or there will be increment in brightness, other thing. We want to add some variation in the x-rays. So how we can add it? We can add a data augmentation, means adding a number of more images with very different variation. So how we can do it in YOLO? During training with YOLO model, you can easily do it with just for the adding some attributes. degree matlab, rotation will be there, translation, scaling, sharing, perspective, vertical flip, horizontal flip, augmentation, saturation values. So these are the attributes which you can easily add and add a data augmentation in your data set. So let me run this cell. So it's getting started. So you can see GPU mem is a GPU memory. Matlab means in epoch how much memory is used in GPU, and box log means bounding box loss, segmentation loss, classification loss, DFL loss. This and here see, you can see that 22 and above is divided by 73. Here 73 is representing the number of patches. You can say, okay. Now this. Now let me explain you this part. You can see that I have told you that when you will run this cell, you will get a run folder. Inside the run folder, segment folder, and this folder name is decided by us. And inside this, you will see the wait folder. And inside the wait folder, you will get two wait file, best and the last. When this epoch one will get completed, you will see two wait file, epoch one and sorry, not best wait file, or you can say last wait file, and the wait file which we use is best wait file. Okay, so how you can load it? Just use model is equal to YOLO, then just keep the wait file. Inside that, run a segment brain tumor, the folder name which will decide wait file and best pt. Now this is a test directory on the images, and this is a class color sample. Here color sample 0 is a basically class ID. You can say one is class ID for representing the brain tumor. Here I'll make the list of all the images present in that particular test directory, and I want to plot 16 images. So for the plotting of the 16 images, 4 rows, 4 column, and each figure size will be 16 by 16. And here figure basically figure representing the entire figure. X is basically for the iteration to the subplots. And you can see this when the epoch one is get completed. When the epoch one is get completed, you can see that your best and last wait file is there. Now after this, for the plotting extra dribble, then for the plotting of the 16 images, I have used I will use for loop for looping over it. And you can see first I will randomly select the image file name. Then for generating the image path, I use os.path.join test image directory, then the image name. This way I get the image path, then I will read that image. And you can see that CV to read the image in BGA format, so I have to convert it to RGB. So here I am converting it. Now I just give the image path. Uh, you can see that when you use YOLO and for the prediction purposes that the model predict the mask or result, you can either give the image path or you can give the directly image. It's up to you. Okay, but here I'm giving the image path. 0 basically just I'm passing the single image. For getting the result of the single image, just use a 0 index value. You will get the result. If the prediction will be there, if result dot mask means it if it is predicted the mask means means a class name or the brain tumor is present in that particular X-ray, so it will go over here. Otherwise, if model had not predicted the mask, it means no brain tumor is present in that particular X-ray. Okay, so if the present is there, then it will go to here result.mask.data, and here segment will be there. Segment after that, segment.cpu.numpy will give me the mask. After predicting mask, or you can say the mask, let me print the mask for you. Okay, and this whole thing, what is happening? I will resize the mask with the image size. Okay, which I am giving according to that, means just passing the image and the image shape one, height or width. According to that, we resize the image, and after that we just give it to the create overlay and blend folder, so not folder, function, which return me the segment image with a segmentation with a color. You can see color upon the segment among the upon above the brain tumor. Okay, like this you can say, means the color above the brain tumor, or you can say the segmented image I get. And image.rgb, after that I will convert that image into rgb and just show the image. And you can see that this is a function. Okay, I already explained this function in one of my video. This is a complete explanation. You can see image segmentation, visualization, overlay, and blending. You will go to my channel and see this video. I have explained you deeply how you can get the segmented image. Okay, so here I will not explain. You can go to my channel and see this video. I also give this link of my video in the description under the description. Okay, so after getting the mask and the segmented image, just plot that and you can use it. So our training gets completed. So now let me run this, and now let me run this also. See here 0000. You can see this is a mask. Okay, but let me break it here. Let me break it just for the single explanation. For explanation with single. Now let me run it again. Okay. Only 00 is showing, but 1 is not showing, where the one basically represent the portion where the segmentation is present, not brain tumor is present. So let me print all the values which is greater than 0. This give me the things that is there any value present a mass which is greater than 0 or not. In this it is not representing, means it's not predicting that a particular brain image has a brain tumor. Okay, see here it is, and you can see one values is also present, and here one basically representing the portion where the brain tumor is present in the image. In short, you can see say that the mask have only two values, 0 and 1, where 0 representing the background, 1 representing the portion where the brain tumor is present at x-ray. And how you can get the segmented image, I have already explained in my this video. So go to my channel and see this video. You will deeply know how you can get a segmented image. So now let me upload see, but in some x-rays brain tumor is there, but it's not predicting very good. So let me upload the model which is trained on 50 epoch and show you the result of that model. Open it. So let me come back when this uploadation get completed. Okay, so the uploadation of the model which is trained on 50 epoch is completed. Let me show you the result of that model. Okay, so I think it is pretty good than the pretty good with the model which is trained on just 3 epochs. Okay, so now you can I have explained you each and everything. I have not explained this whole code how you can generate a segmented image, because I already explained this in this video. Go to my channel and see this video. You will deeply know how this function is working. Okay, so please like, share and subscribe. Thanks to all.